So right now I am going to start units and dimensions. One shot. I will try to make it one shot. Let's see. So units and dimensions. So see, here like we have two types of quantities. One is fundamental quantity and the others we call derived quantity. Okay. So fundamental quantities are those quantity which does not require any quantity to be defined. Okay, so those quantities which does not require any other quantity to be defined, they are called fundamental quantities. Basically they are independent. So these are independent quantities. Independent. Derived quantities. These quantities are dependent on fundamental quantities. That if you know fundamental quantities, then only you will be able to know derived quantity. So these are called dependent quantities. For example, fundamental quantity, how many fundamental quantity we are having? 7. See, what are fundamental quantities I am writing here? Like mass, then we have length, then we have time, then we have temperature. Mass, length, time, temperature, 1, 2, 3, 4. Then we have amount of substance. Okay, amount of substance. So moles. What is the SI unit of amount of substance? Moles. 5th. Then we have current. And then we have last luminous intensity. Luminous intensity. So these are independent quantities. These quantities does not require any other quantity to define. Like suppose you want to say mass. So will you take any other quantity in order to define mass? No. They are self-sufficient. Correct? So mass, length, time, temperature, mole, current, luminous intensity, these 7 are fundamental quantities. Okay. SI unit you know, mass kg, length meter, time second, temperature Kelvin, this amount of substance mole, current ampere, luminous intensity candela. Okay. And derived quantity. So these quantities are derived from fundamental quantity. For example, see, you will understand the difference here. Like area. So area is what? Length square, length into breadth. So we are taking the help of length, fundamental quantity. See, we are taking the help of fundamental quantity to derive this quantity. Okay. So area. So see, what is the SI unit of area? Meter square. So basically this is length square. So it depends upon length, na? If you don't have a length, we can't define area. Correct? Similarly, like anything you say, force. Suppose force. What is force? Force is mass into acceleration. So mass into acceleration. Now what is acceleration? Rate of change of velocity. How much velocity is changing? Change in velocity by time. So see, this again force depends upon fundamental quantities. It depends upon mass, which is fundamental quantity. It depends upon time. It also depends upon change in velocity, and change in the velocity is what? Meter per second means length divided by time. So again it depends upon all these fundamental quantities. So these quantities are derived quantities. Always remember that these 7 are fundamental. Anything you get other than these will be what? Derived quantity. Okay. So you just remember these 7 fundamental quantities. Okay. See, small conversion basically we will understand. Conversion. You must be knowing that 1 kg equals to 1000 gram. 1 meter equals to 100 centimeter. 1 centimeter equals to 10 millimeter. Then some others also, like 1 meter cube, 1000 liter. These things you should understand. Okay. See, like we have two kinds of units. Like one is MKS system. MKS. We have two types of system. This is MKS system. M is what? Meter. K is kg. And S is second. Meter, kg, second. Whenever a certain unit you express in meter, kg, second, that is MKS system. And suppose you express in CGS. C for centimeter, G for gram, S for second. So this is CGS system. Okay. Like for example, if I say, suppose I am saying that CGS unit of force is dyne. CGS unit of force is dyne. For example, this example, see how I am going to do. Okay. So they will ask, okay, that 1 Newton equals to how much dyne? Suppose this is the question. You should remember the value also, but how we are going to do now? Just see. Any kind of question you get now from MKS to CGS, you will be able to solve. Like see, you know that force SI unit is what? Newton. I am saying that force SI unit is what? Newton. And CGS unit they have given it's dyne. Now we have to say 1 Newton equals to how much? Dyne. So see, force is what? Force is basically mass into acceleration. Correct? So 1 Newton force, can I write 1 kg mass, acceleration what? 1 meter per second square. Force is equals to mass into acceleration. 1 Newton force, what we can take? 1 kg mass and acceleration 1 meter per second square. Now this we have to convert in CGS unit. So see how we will do. What I am saying, 1 Newton, this is force. Force equals to mass into acceleration. So you take 1 kg mass and acceleration also you take 1 meter per second square. Now can I write this 1 kg 1000 gram into 1 meter, that is 100 centimeter per second square. per second square. So what we are getting? 1, 2, 3, 4, 5, 10 to the power 5 gram centimeter per second square. Correct? So centimeter gram second. Now we have got in CGS, and CGS unit they have told, this CGS unit they call this dyne. So 10 power 5 dyne. So 1 Newton equals to 10 power 5 dyne. See, suppose energy, see energy SI unit or MKS unit and CGS unit. Do you know energy SI unit? What is the SI unit of energy? Joule. So this is joule. And CGS unit of energy? Erg. Now they will ask 1 joule equals to dash erg. Try to find out. 1 joule equals to dash erg. So joule is the CGS unit of energy. Now they are asking 1 joule will be equals to dash erg. See how we are going to do. Think of any formula of energy, any formula. Like we have lot of formulas. You can think about kinetic energy. Kinetic energy is also energy, na? Potential energy is also energy, and potential energy formula everyone remembers, mgh. So potential energy I am writing, think of any formula. So mgh. So can I write 1 joule equals to 1 kg mass g. So 1 meter, g is what? Acceleration due to gravity, na? So 1 meter per second square into 1 meter. Correct? Now see, 1 kg we can further write 1000 gram. Again 1 meter, 100 centimeter per second square. Again 1 meter, 100 centimeter. So this is coming 10 to the power 5, 10 to the power 7 gram centimeter per second square. And this CGS unit they are saying erg. So 1 joule equals to 10 power 7 erg centimeter square. Okay, correct? So 1 joule equals to 10 power 7 erg. correct? See, you must be aware of units, SI unit like this. Like for speed or velocity, what is the unit? Meter per second. Meter per second. Like force, unit Newton. Unit is Newton. And force is what? Mass into acceleration. Force is what? Mass into acceleration. So we can write mass, that is kg, acceleration, that is meter per second square. We can write like this also. Correct. Now next is dimension. So these are the units, SI unit. Dimension. Anything which is written in the form of m to the power a, m is mass, l to the power b, and t to the power c. When you write something in this form, this is called the dimension. Like for example, force they ask, what is the dimension of force? They will write like this bracket means dimension of force they are asking. So you have to express force in this form: mass to the power a, length to the power b, time to the power c. So what is the think of any formula of force. Force equals to mass into acceleration. You can write a mass into acceleration. Force is mass into acceleration. Now you write the dimension of mass, dimension of acceleration. Now if you don't know what is the dimension of acceleration, how acceleration comes? See, mass I am writing this, mass I am writing like this, mass into acceleration is what? Change in velocity. How much velocity is changing? In how much time? This is only acceleration, correct? So can I write this further as mass? This is velocity na? Here if you write something, this will be velocity. What is velocity? Distance by time. So distance by time, distance divided by time, this is velocity, again divided by time. So again divided by time means here time square can I write. So mass you can write m, only one, nothing is there means power 1. Distance is what? Length, so length to the power 1 divided by time square, divided by time square or time if it comes up, so t to the power minus 2. So ml t to the power minus 2, this is the dimension of force. Now I will say just remember one formula, means one dimension. See, whatever dimension they ask in the exam, it is easy only, just you calculate there only, but one dimension you remember, this force dimension, ml t minus 2, only this one, only one I am asking you to remember, ml t minus 2, mass into acceleration, mass acceleration. Okay. Now if someone asks you what is the dimension of acceleration, so this is mass, this is acceleration. So acceleration is what? L t to the power minus 2. Now if someone asks what is the dimension of energy, energy dimension. Now think of any formula of energy. So energy is again kinetic energy, potential energy, mgh. Correct? So ठीक है, half mv square,
ml square t minus 2, ml 2 t minus 2.
हाँ
नहीं कुछ ये बोल रहा क्या आएगा
any formula. अच्छा, energy, what is the unit of energy? Joule. Okay. What is the unit of work? Joule. So dimension of energy and dimension of this work will be same. Always remember, if the units are matching, definitely their dimension will also match. Correct? So you can do by unit of force also, unit of work also, or you can use any formula like mgh, mgh, correct, or half mv square, whatever. So m is mass, I am writing m. Acceleration, g is acceleration, na? So l t to the minus 2. H is what? Length. H is length, so again you multiply one length. So how much it is coming? M L square T minus 2. If I have used the formula this energy, like kinetic energy, half M V square. So see, any number, I will come to this, any number has no dimension. So this is 1 by 2, na? 1 by 2 will have no dimension. So mass dimension m. What is velocity? Meter per second. See, what is velocity? Meter, that is length, per second, or L t to the power minus 1. So velocity is square. So L square t to the power minus 2. See, this is velocity square. So if I do square, so L square, and here see V square I am writing. So here L will get squared and t to the power minus 1 square. So t to the power minus 2. So L square t to the power minus 2. See, same answer we are getting, na? Correct? So always take any formula and which is easy. Okay, like MGH I find very easy. Okay, everyone knows. Correct? And one more thing, if the quantities have the same unit, like work, if they ask now what is the dimension of work, so you know that SI unit of work is what? Joule, and SI unit of energy is also joule. So if they are having the same unit, definitely they will have the same dimension. So if someone asks what is the dimension of work, so you can write like this, ml square t minus 2. And work you can think like this also. What is work? Force multiplied by displacement into cos theta. But cos theta will no dimension, na? Cos theta is a ratio 1 by 2, 1 by root 2, like this. So force multiplied by displacement. Now what is force? I asked you to remember ml t minus 2 multiplied by displacement means ml square t minus 2. See, it is coming. So you can remember, write also, same unit, same SI unit, same dimension. Same dimension. Example, work and energy. Both of them are having the same SI unit, that is joule, and therefore both are having the same dimension also. Now we have some rules for dimension. Some rules dimension. What are the rules? See, with the help of example I will make you understand. Like for example, there is a formula S equals to ut plus half at square. Okay. This is the formula. So always remember, if we are adding things or we are subtracting things, so each and every term will have same dimension. Means, see, for example, like if I say you have to add 2 meter plus 3 meter, so what will the answer? Total 5 meter. Means if I ask that add 2 meter plus 3 meter, so what answer you will get? 5 meter. Correct? Achha, if I ask you add 2 meter and 3 meter square, you will say, sir, how we can add? Because one is meter and one is meter square. Meter square is area and meter is length, so we can't add. So always remember, we can add, we can subtract only when each and every term have the same direction, same dimension. Like this is having the dimension of length. This will also have the dimension of length only. And the result we will get, that will also have the dimension of length. Means this term, then this term and this term, all three terms will have the same dimension. And what is this? S is distance. So distance dimension, length, L, only L. See, its dimension, if someone asks, this is S means distance, na? Distance means length. So dimension will be only L or L to the power 1. Or some books they will write like this, M0, L1, T0. If nothing is there, means M to the power 0, L to the power, like here in this case, M to the power 0, M is not there, na? So M to the power 0, L to the power 1, time is not there, so T to the power 0. So means all this quantity will also have same dimension. Similarly, this quantity will also have the same dimension. Correct? You can check also, see, UT, let's check. U means velocity. Velocity dimension, meter per second. This is meter per second. Multiplied by time. Multiplied by time. Time means power 1. So L minus 1 plus 1, 0. So T to the power 0. See, only length comes. Only length is coming now. You can write M also. M to the power 0 also. Mass is not there. So see, M0, L1, T0, M0, L1, T0. So all these three terms will have the same dimension. This is called law of homogeneity. Law of homogeneity. So if we are, what is just, I will not write the full sentence. If we are adding or we are subtracting, then each term will have same dimension. Each term will have same dimension. So this is the first point. Second point, any numbers will have no dimension. Like if I ask 1 by 2, so what 1 by 2? Mass is not, I am not saying mass, I am not saying meter also, I am not saying time also. So any number, no dimension. So always remember second point, that numbers have no dimension. Third, log values, log of something. So logarithmic terms, exponential terms and trigonometric terms, these are also having no dimension. I will tell you what are these. See, any number has, means if I take any number, it will have no dimension. Like 4, what dimension will have? No dimension, no? So 4 is 4 only, no dimension. So if I say log of x square, suppose, okay, or I will give one example. Y equals to log of 80 see this carefully. Y equals to log of 80. What they are asking, what is the dimension of y, what is the dimension of a, where t is time, see this carefully. So log of something, now something means, see, we calculate what, log of 10, log of 9, so 80 will be a number, na? So 80 will have no dimension, this term will have no dimension. Like, see, two things you have to understand. Like we say log of 8, for example, is 0.9. Log of 8 value, actually it comes 0.9. So log of 8 is 0.9. So this 8 is number, na? Number is having no dimension. And whatever we are getting whole value, that is also a number. Log of 8 is what? 0.9. This is also a number. So this will also have no dimension. These two will have no dimension. Means this 80, this is a number, no dimension. So 80 will be m into m, no dimension means m0, l0, t0. So if someone asks what is the dimension of a, so t will go down, na? T will go down. So m0, l0, t to go 0 by t. T will go down. So m0, l0, t minus 1. This is the dimension of a. Correct? This is the dimension of a. Now if someone asks what is the dimension of y, what is the dimension of y? See, log of something we will get some value, na? Like log of 0.8, 0.9. So this was a number, na? A number has no dimension. So y will have no dimension. This will be m0, l0, t0. And a we calculated m0, l0, t minus 1. Write this one more example I will take. See, suppose one example I am saying, velocity equals to beta sine of c x cube. They are asking that tell the dimension of beta and you have to tell the dimension of c. See, once try to focus. And v, where v is velocity and x is distance. Correct? They are asking the dimension of beta, they are asking the dimension of c. See, sine of something. So this will be a number, not 30 degree, 60 degree number. Number has no dimension. So cx cube will have no dimension. Means this will be m0, l0, t0. Why? Because this will be a number, 30 degree, 40 degree, 80 degree, no dimension. And I have written also, any trigonometric function, no dimension. So dimension of C if they ask, so M0, L0, T0, this x cube will go down. X is what? Length. X is what? Distance, na? So distance cube means L cube. So finally it is coming M0, L to the power minus 3, T to the power 0. This is the dimension of C. Now, again, look here carefully. This complete sine theta, this will also have no dimension. Why? Because sine theta will have some value, na? Like sine theta 1 by 2, sine theta 1 by root 2. So sine theta complete will also have only number only. A number has no dimension. So this is having no dimension. This is velocity. So beta will have the dimension of velocity, na? This is velocity. This is no dimension. See, velocity dimension. Velocity is what? Meter per second. Velocity is what? Meter per second. So meter per second equals to beta, and this is having no dimension. So M0, L0, T0. So beta, what we can write? This will go down from here. We can write beta equals to LT minus 1, M0, L0, T0. So this is nothing. M0, L0, T0 means 1. So this is what? LT minus 1. And think this complete term is having no dimension. And this is velocity, meter per second. So meter per second means L T to the power minus 1. So this will also be T minus 1. Both sides has to be equated, na? L T minus 1. Okay, see. Now some people think like we have formula F equals to G M1 M2 by R square. So if they ask what is the dimension of G, so they are saying 0, M0, L0, T0. Why? Because it is a number. No. Number means only number. Like kinetic energy half mv square. So half number, it has no dimension. But someone asked G, so you calculate like this. What will be the formula for G? You cross multiply F R square by M1 M2. So force is ML P minus 2. Distance square L square divided by M1 M2 M square. So 1 minus 2 minus 1 L cube T minus 2. This is the dimension of G. This is the dimension of G. Last example, like C. P equals to C divided by rho minus D. This is last question I am discussing. So P is pressure. They have given that P is pressure. Rho is density. You have to tell the dimension of C. as well as dimension of D. Okay. Correct. Now see how I am solving. This is density. Density minus G. We are subtracting now. So both will have the same dimension. I told now. If you are adding or if you are subtracting, all the things will have same dimension. So this and this will have the same dimension. So dimension of D will be dimension of density. Dimension of D will be dimension of density. So dimension of D will be dimension of density. Dimension of density. What is the dimension of density? Density is what? Think of any formula, mass by volume. Density is mass by volume. So mass by volume you can write L cube. Correct. So m L to the power minus 3 T to the power 0. Correct. Acha, this complete term, this complete will be having dimension of density only. Density minus density, so density. So can I write dimension of C equals to cross multiply. So this is density. Density means this one. M L density is mass per unit volume. This is density. Multiplied by pressure. Pressure is what? Force by area. Force MLT minus 2. This is force divided by area, that is length square. Now you can calculate M. L minus 3 minus 2, L minus 5 plus 1, L minus 4. M square L minus 4 T to the power minus 2. This will be the dimension of C. C equals to cross multiply. Here a dimension we know, M by L cube or ML minus 3, and pressure is what? Force by area. Now using dimension, you can also, means 90%, expect the formula of any quantity. Like for example, another kind of question what they ask, they will say pendulum time period. Pendulum you know na? So time period of a pendulum depends upon length as well as G, acceleration due to gravity. So time period of any pendulum depends upon length, it depends upon G. Using this information, you have to understand the formula of time period of pendulum. Okay, see how we do. How we will do? We will write time period is directly proportional to length they have given, so we will write length. Power we don't know, we will assume power A. It also depends upon G. So power we don't know, we will write B. This is the process how to do. So next step equals to some constant. We will write some constant L to the power A and G to the power B. So from here time period equals to some constant length to the power A. So length dimension L to the power A. G is what? Acceleration due to gravity. So acceleration is L meter per second square. This to the power B. This is acceleration. So acceleration to the power B. So see how much it is coming. T equals to K. L to the power A, L to the power B. So L to the power will be added. Here L to the power A, here L to the power B. So A plus B. Time T to the power minus 2B. Now here this left side and right side should match na. But what we can see, left side there is no length term. So we can write like this also. Left side we can write M0, L0, T1. So here M0, and the right side also we don't have mass. So okay, leave it. No mass, you leave it. See, length 0, here length is what? A plus B. So this A plus B should be equals to 0. Time 1, time minus 2B. So my here minus 2B should be equals to 1. So B should be equals to 1 by 2 minus 1 by 2. Now if I substitute this, B equals to minus 1 by 2, A will be what? 1 by 2. Because 1 by 2 minus 1 by 2 will be 0. So from here A becomes 1 by 2. See, we got the value of A and B. We got the value of A and B. So time period we can write constant L to the power A. A is 1 by 2. So L to the power 1 by 2. G to the power B. So G to the power B is what? Minus 1 by 2. So equals to K root L. G to the power minus 1 by 2 means 1 by G to the power 1 by 2. 1 by root G. So under root L by G. Constant under root L by G. Only constant you will be not able to get. What is the constant? But all other formulas you will be able to write. See, one more question I will take. Like for example, they say that force depends upon mass, velocity and radius. Force depends upon mass, velocity, radius. You have to tell the formula for force. So how you will do? How you are going to do? First you will write force directly proportional to mass. So you write mass. Power you don't know, so you write A. Then velocity, you write velocity. Power you don't know, so you write B. Then radius, you write radius. Power you don't know, so you write C. Correct. Now this side you write the dimension of force, that is M L T minus 2. This is the dimension of force, equals to some constant mass. So mass is M to the power A. Velocity, what is velocity? Meter per second. Meter per second. See, meter per second. This to the power B. Radius. Now what is radius? Radius is length only, na? Radius is length only. So length to the power C. Now you have to do the mathematics. See, here K, M to the power A. Tell me L to the power how much should be? We should write. Here L to the power B, here L to the power C. So L to the power B plus C. So L to the power B plus C. Time to the power minus 1 into B. So minus B. Now see, compare from here. A should be equals to 1. M to the power A, M to the power 1. So A should be equals to 1. Minus B should be equals to minus 2. Minus B should be equals to minus 2. So B should be equals to, see, minus B should be equals to minus 2. Minus minus cancel. So B should be equals to 2. Length 1 should be equals to what? B plus C. So 1 should be equals to B plus C. So 1 should be equals to B is over 2 plus C. So 1 minus 2 minus 1. C equals to minus 1. So what we can write? force equals to mass to the power A. So mass to the power A is what? 1. Velocity to the power B. So velocity to the power B is over what? 2. Radius to the power C is what? -1. So r to the power -1. We can write like this also, mv square, r we can set down, so mv square by r, centripetal force. See, another kind of question how they make, another kind. If force, acceleration and time are taken as fundamental quantities, See, actually, tell me, is force fundamental quantity? No. Force is not a fundamental, this is derived quantity. But they are saying if force, acceleration and time are taken as fundamental quantity, then length will be equals to what? The length will be equals to what? See, this kind of question, similarly, just like previous question we solve. We will write length is directly proportional to force to the power A. Acceleration, it depends upon acceleration also. So acceleration to the power B, and time, so time to the power C. So length means m0, l1, t0. This is the dimension of length. Equals to some constant. Force is mass into acceleration, m l t minus 2. This to the power A. Acceleration, meter per second square to the power B. Time to the power C. Now same thing you will do and you will write the answer. So I will tell you what A, B and C are coming. A 0, B kitna?
B1.
If you solve this, A is 0, B is 1, C value 2 I think. -1. 2. Means finally what you can write, length equals to some constant, force to the power A, so F to the power A is 0, acceleration to the power B, so acceleration to the power 1, time to the power C, so time to the power C, that is 2. F to the power 0 means 1, so you can write length equals to some constant AT square.